Alright, here we go with some test your understanding. For each of the following forces, state the type of force, the object, and the agent. So the first thing we're going to look at is your own weight force. So we know that's a weight force. We know that's a weight force. Okay. The object is you. And the agent is the earth. The earth is exerting a force on you. The force the floor exerts on you, that is a normal force because it is a surface and it's perpendicular to the floor. The object here, again, is you. And the agent this time is, that's right, the floor. The force that accelerates a car on a flat roadway, that is friction. Friction. The object is going to be the car. And the agent is going to be the road. You're walking your dog, the dog lurches at a squirrel, but you use the leash to prevent the dog from getting away. Alright, so the type of force here in the leash is the tension. The object is the dog because you are pulling back on that leash, so you're exerting a force on that leash. And then the agent, because you are exerting the force, is you. State Newton's third law, not writing for every action there's an equal but opposite reaction. I'm not going to write that because it's going to take me forever. But if A exerts a force on B, then B exerts a force on A. Equal and opposite. Equal magnitude, opposite direction. Because force is vector, right? Opposite. There we go. That's the first little piece. Alright, next up. In each row, select the correct important point about the forces in a Newton's third law pair. Okay, so in each row of the table. The important one. Two forces in Newton's third law act on the same object. We talked about this extensively earlier. That's not the case. You have to have multiple objects to have a Newton's third law situation. Two forces in Newton's third law act on different objects. Yes, true. Two forces in a Newton's third law pair always cancel. They're only going to... No. They cancel. Forces cancel if they're acting on the same object. But if they're not acting on the same object, then the forces aren't going to cancel. Right? So that's not true. Two forces in a Newton's third law pair never cancel. That's mo like it. The action force acts first, then the reaction force acts. No. They have to happen at the same exact time. The action force and the reaction force can be different types of forces. No, sorry. It's got to be the same type of force. One of the forces is a push, and the other force is a pull. No. Both forces are push or both forces are pull. It's the same thing as the action force must be always the same type of force, right? So then it says for each situation. Oh, this is on the next page. For each situation, fill in the table. We'll do that now. A light girl and a heavy boy both sit on a nearly frictionless cart. The girl and boy push off of each other's hands. So let's fill this in. The boy exerts an applied force. Applied force to push. Looking at the picture, he's pushing left. The boy is the big one. Sorry for the gender here on the girl is the object. And then sexism to top it off. Sorry. The effect is the girl will speed up. To the left. Reaction. The girl exerts an applied force. Remember, it has to be the same type of force, right? Applied force to push. It's got to be the same type. If it was a pull, then it would be a pull. Right, equal magnitude, opposite direction on the boy. So the boy will, the effect is, speed up to the right. Alright, next we have a light girl and a heavy boy. Both sit on nearly frictionless carts. The girl and boy hold opposite ends of a rope. Both students pull the rope towards themselves. Assume the boy is twice the mass of the girl and that the carts have very little mass. Okay, so again, we'll start off with the boy exerts a tension because there's a rope involved, right? To pull right on the girl. And the effect is the girl is going to accelerate to the same, she's going to accelerate in the same direction as the force acting on her. So she's accelerating to the right. Okay, and by now I'm sure you can figure this out. The girl is going to exert same type of force. Pull left, opposite direction of the boy. We have two objects here. That means we can have a Newton's third law pair. The boy is going to then accelerate to the left.